When using streaming software to play games, latency is the top concern. I'll use the hardware platform I built earlier to test the input latency of several streaming methods. Input latency refers to the time from pressing a key or clicking the mouse until the game responds on screen. The principle for testing latency is as follows, which was explained in a previous video. The RK3588-based IP KVM system. It can capture the HDMI signal output by the PC and send mouse and keyboard control signals to the PC via HID. This allows full interception of the PC's input and output. By recording the timestamps of mouse/keyboard operations and the timestamps of screen changes, we can obtain the actual input latency. Of course, during actual calculation, we will exclude some internal processing time and HDMI input latency. Since I want to compare the latency of Unreal Engine Pixel Streaming, the game tested is a built-in sample from UE5. The streaming sender uses an RTX 4090 GPU, and the receiver uses a GTX 1660 Super. The resolution is 1920 x 1080, and testing over a local area network eliminates performance and network bottlenecks. The testing process is as follows. Stream the same game separately using Parsec, Steam, and Pixel Streaming, and find an area with no distractions. Then manually start operating, and the program will automatically record latency data. At this stage, the latency isn't visually obvious and can only be judged by feel. Once testing is complete, I'll collect the data and plot it for latency comparison. Here are the collected latency results, a box plot on the left and a moving average chart on the right. Looking at the box plot in detail, the left, middle, and right represent Pixel Streaming, Parsec, and Steam respectively. Steam has the lowest latency with a median and average of just over 30 milliseconds. As expected, Pixel Streaming has the highest latency due to running in a browser client. Parsec's latency is still higher than Steam's streaming. The moving average data also shows the fluctuations of each streaming method. Overall, under the same test environment, Steam streaming delivers the best latency performance. Later, I also tested running this UE5 application directly on the 1660 Super GPU. The latency was almost the same as Steam streaming, even slightly higher in some cases. Analysis suggests this is because the 1660 Super cannot maintain full frame rates. Finally, if you have any other tests you'd like to see, please leave a comment below the video.